All right, so we are 2 minutes in, and let's get started while other attendees can stream in, right? So, okay, so welcome everyone, and thanks for attending the webinar on Whitebox AutoML, techniques for creating interpretable models. My name is Chetan. I'm from H2 and I work as an AI architect. I'll be co-hosting today's event along with Oksana, who's our marketing director at H2O. So at both H2O and CBA, responsible AI is a topic which is top of our minds. There's a lot of emphasis both at CBA and H2O in ensuring models built are fair, equitable, and transparent. As an AI platform provider, we are committed to supporting features and capabilities to help organizations build transparent models. And CBA being an industry which is highly regulated, it is imperative that we build models that are explainable and trustworthy. Today's webinar is the third and final part of a series of events on responsible AI. Late last year, we had Dan German, the Chief Decision Scientist from CBA, along with Ed Santo, former Australian Human Rights Commissioner, Aurelie Jacquet, Chair for Standards Australia for AI, participate in a panel discussion. Today, we have Luis Pizzato, Executive Manager, AI Labs at CBA, and Shivam Bansal, Senior Data Scientist and 3-time Kaggle Grandmaster, talk about techniques for creating interpretable models. Can I go to the next slide, Oksana? Cool. So yeah, here's a agenda. I'll keep it very brief. Today's session comprises of 2 segments. In the first one, Louis will focus on applied perspective of fairness, accountability, transparency, and explainability of ML models, and how responsible AI or ethical AI is an integral part of CBA's ML landscape. In the second one, Shivam will focus on MLI, the key ideas and techniques one can use in developing explainable models. So before we get started, just a few housekeeping items. We do have a dedicated Q&A session, as mentioned in the slide, towards the end for 15 minutes. But feel free to drop in your questions during the talk in the Q&A widget. Some of the questions may be answered during the session by one of the speakers or moderators, and we'll definitely pick some of them as part of our Q&A. Over to Louis. You want to get started?
Thank you, Chetan. So welcome everyone. Thanks for inviting me to present our perspective on AI, responsible AI, and how we do. Oh, Oksana, maybe. Yep. Thank you. I think I can control the slides. So what I'm going to talk to you today is about obviously explainability, about using responsible AI in the bank, more from the applied perspective, and then Shivam is going to talk about some of those techniques. And so first of all, I just want to provide a little introduction to myself. Who am I, right? I'm a computer scientist, data scientist for more than 20 years, been working in the AI field, got a PhD in the area, still an academic by heart. This is the great thing about my role, and I'll talk about my team very soon. And I do have an expertise in natural language processing and recommender systems in online dating, right? That's a completely different topic. We can talk hours about it. But today we're going to talk about responsible AI. And my team at CBA, we work with, the team is called AI Labs. As the name implies, we are a bit of a research and development team at CBA. There are many CBA teams they're doing data science and machine learning. We say we have the front line in the AI revolution. What that means is that we are looking at what leading companies are doing in the space, H2O in one of them. All the research is coming from the top universities. We are doing collaborations with universities. We are making sure that everything that we see in the market and also have very capable expertise, they are developing these new techniques and these new things in AI and how that can apply to the bank and the industry. We also very much looking to apply this technology and leading the bank to do very good things with this technology. So some examples that come out of my team is the detection of abuse in transaction description, right? Trying to make sure that we do AI responsibly across the bank and the industry. So there's a lot of innovation in that space. We are absolutely right in the middle of the bank and try to guide the bank into some of these aspects. But let me just go through what we're going to talk today. So I'm going to start using, just make sure that we understand that responsible application of AI is something important, right? We're going to look a little bit of history of CBA and responsible AI, as well as a use case that we had on one of our AI products, which is BuildSense, and how we apply that to the government framework. Then I'm going to talk about explainability in banking, which is obviously very important, and how we ensure that fairness is applied across our models and AI systems. So it's AI ethics, AI using responsible AI is something that we all say it's very important, and we see this all the time, people talk about it. Why is that obviously important? Ethics and AI is a difficult thing, right? It's not an easy issue. We can say, look, we apply responsibly, we apply with trust, we provide transparency, and not necessarily is that easy. A lot of ethical questions are difficult ones. As I was mentioning before, we need to ensure that we apply AI for social good. And this example that I just mentioned as well, like that we are applying AI, for instance, to detect abuse in transaction descriptions, right? This is obviously very for the social good type application of AI. But there's a lot of potential for good in AI, right? Like people think about AI and they start thinking about the risks, right? That once the AI turns sentient, like general intelligence, they're going to take over the world and it's going to kill all human beings. That might be true one day. We obviously need to be ready for that. We need to ask the right questions and be prepared for a situation that when it comes really serious ethical questions. Currently, we have situations like AI can help healthcare, democratize healthcare, right? You hear about things like radiology and detecting cancer and tumors better than an expert. It's probably not quite better than all the deep experts, but what it can do on that is democratize medicine. You can bring things much faster and better for places that lack the skills, right? So that's obviously very clear. There's a lot of good that AI can bring to the world, right? But there's potential for other things like amplifying biases, right? We have biases in day-to-day and how people interact with other people. There's stereotypes and things that needs to be broken down. Now, if the data that we have is biases, is our AI amplify those biases, or it actually helping solving a problem, right? This is something we deeply think every time we're building models, right? Now, how do we solve that problem? How do we make sure that the biases are not in our models, everyday models? That's deeper questions. Sometimes you need to solve things. Sometimes you probably can do more harm if you do that. So there are a lot of questions to be added there. The third panel you see is talk about trust, right? Trust is another very deep issue in AI, and there's a lot of things that when you talk about society and people, they will be asking a lot of questions about how can we trust the AI, how can we trust the system. A lot of times it's more about the trust in the institutions developing the systems than the systems themselves. People will trust if they trust the company that's doing that, because they know that the company is doing the right things for their customers. So there's a lot of questions there. There's a lot of things that people need to do. And obviously trust is a very sensitive issue that at some point, if you break that trust, people won't trust you anymore. And just to highlight as well, well, trust in particular, there's obviously a lot of issues we trust and how people perceive AI, right? So you can imagine that a lot of automation systems, a lot of things you see in the media that people don't trust the AI, people that happen this, a lot of times it's not actually an AI system. It's actually an automation system, but it gets perceived as an AI system. So it's important, obviously, to understand what AI is, what's not. But it's also important for companies to think that it's not necessarily a responsible use of AI. It's a responsible use of technologies, right? So we need to think about technologies end-to-end. We need to think about technologies on the consequences. And an example I always give is like adding a thumbs up or a thumbs down in a social media type of company, right? Has very deep consequences of people behave. And that's not necessarily an AI system, right? So anyhow, let me move on. I love talk about these things, but I know I have a lot of content to go through. And because of that trust, obviously people are worried about how AI is being regulated, right? There's obviously support from public about that we need to regulate companies and they shouldn't be doing the wrong thing, and we should establish principles of AI. And you can see a very push in many governments around the world. The Australian government has set some standards, the framework for responsible AI, for ethical AI. So there's again guided principles that people should apply. It's not mandatory, but people should rely on them and make sure that they're developing things correctly. Same thing, European Union is thinking about adding some regulation in the space, which is something that we obviously look very closely to it. We have been quite active in this space for many years. So CBA has been thinking about AI ethics for many years. We've been doing AI systems for many years. There's a lot of modeling involved in, obviously, banking, and a lot of regulations, obviously, that regulate and govern us how we do those modeling. What I'm showing you here on the left side is so we implemented to help our modelers to look at explainability of systems, but also looking at potential disparities and biases, right? So people can actually correct and work on it. I'll talk a little bit more about it very soon. In the middle here is just highlighting that we actually been collaborating with government on development of our AI frameworks, ethical AI frameworks, and there's we have a use case on Bill Sense that I'm going to talk about it as well. And we've been very active in collaborations with universities and research institutions that actually work on the ethical AI space. And so for many years, that's a problem that we're thinking for a long time. Let me just walk you through one particular example of where we really think about the ethical issues and the framework, the Australian government framework, and how it applies to a AI product that we have in CBA. So if you don't know, Bill Sense is a AI feature that we have in our CommBank app, in our banking app. You can access this use case into the link that you see on the page. So what Bill Sense does is it goes through your transactions if you're a customer of the bank, and it predicts when the next bills are going to come, right? That seems like a trivial problem, but if you think about bills, they have very different frequencies, right? You might pay a bill once a month, you might pay a bill once every week, you might pay a bill once every fortnight, every 6 months, and so on, right? So what that allows you as a customer of CBA is actually to look at your commitments for the month. So you know how much you receive in your salaries, everything, your other commitments, but can you really know all the bills that you need to pay? And that provides you a very clear view that there might be X amount of dollars that you need to pay this month. So there's a lot of things. If you look at the principles on the right side here, we need to ensure the human, social, and environmental well-being of customers when you're developing AI system. And obviously, this is a system that is entirely for the benefit of the customer, right? There's no commercial value to it, but to say we're helping you manage your bills, manage your commitments. On human-centered values, the person has full autonomy how they want to use the system. They can opt out of Bill Sense. They can decide whether a bill should be there or should not be there. They can override bills. They can override values. If something is predicted, it's very clear, and that goes for things like transparency and explainability, that we are very clear of the use of AI, how we're using, how you're using, and how actually this bill you can override, and you can actually say exactly correct the values if that's needed. Same thing with fairness. There's no discrimination. There's no different population will receive a different thing. Every single customer in the bank has access to that same Bill Sense features. Privacy, protection, and security. We obviously, as a financial institution, there's a lot of controls and there's a lot of focus on privacy and security. We do have obviously a lot of controls on privacy. We do have a lot of regulations that we are obliged to, and there's a lot of things in this area. So on reliability and safety, as you can imagine, every model is very well managed. So we have a group model policy. There's controls on how you actually ensure changes in models. There's controls on how the performance of the models are happening. There's compliance and governance on everything. So you can imagine if something goes wrong and we identify that the model is going wrong, we can actually pull a plug and either turn it off very quickly, a kill switch, or we can actually move to a previous version of the model that was working correctly. So you always have that control. And the last aspect here on the contestability and accountability, there's absolutely a way for the customers to provide feedback, right? Is either picking up the phone and calling the bank and say, this is something wrong on my bill sense, right? Or providing feedback on the app. And those things are very well followed through in our teams to the teams that are responsible. And every single part of the system has accountable parties. And you can imagine every single data point that we use, there's an owner and there's someone who's responding for that information. And obviously, we know who is responsible and people who chase up the things that are in their domain. So there's a lot of managed control and into the bank, and all of these things really tied up to how we actually ensure that we're doing things responsibly and properly towards our customers. Now, some areas are obviously different to others, and I did mention that explainability is a very important thing in the bank, right? And I'm not necessarily doing much things like capital models and credit risk models in my team. So I had to get a lot of information from colleagues on this area. But as you can imagine, explainability is super important, right? And I put here as an almost near requirement in some of the regulated areas, right? And what I mean by that is that it's not particularly explicit that you have to have a model that can be explained, right? Like, and you always think about simple models like a linear regression model, right? That you can dip down, pick into the coefficients and tell exactly what you're doing. But what is important here is that what we're doing in this important regulated models like capital models, credit risk models, we have a very clear policies and standards for how we do modeling in those areas. Right, so we're going to be defining the approach that we can do on modeling, how we're actually going to monitor it, how we're going to design those models, how we're going to measure performance, how we're going to validate, how we're going to do the governance of those models, any changes, documentations. Those things are very well documented and they're kept for a long time because obviously some of this would need to go back to the regulators to approve, and that communication to the regulator involve things like, why did you decide to use this variable on this model in particular? So every single variable and every single decision that you put in the model needs to be well explained. And that means that even though the explainability component, maybe the model don't necessarily need to be explainable as per se, you need to be able to explain to a customer, you need to be able to explain to a regulator why a decision was made. And those things are obviously much easier in some scenarios. So we always, when we're modeling this type of models, we ensure that everything can be explained really well. So it's almost like a near, as the same requirement that we have, right? So that's how we treat this. The other, and the last slide that I have here is to talk about fairness. Obviously, fairness is something that is intrinsic to CBA values, right? And us, we always make sure that the people are treated fairly and appropriately by everything that we do in our interactions with customers, which means that our modeling is no different, right? We expect our AI to behave as a person would behave towards someone. Now, we do have a lot of controls to make sure that there's any reduction of bias or any intended bias can be identified. But also there's a lot of controls in our policies and our modeling standards to say, how can we actually try to minimize any biases in our modeling? And some of these are things like prohibitive variables, right? For instance, we will never do modeling using something like gender in the model, right? Or marital status or any other sensitive information that you shouldn't be using for that purpose, right? So every variable that you're going to use through a modeling, you need to have a purpose to use that. Now, that doesn't, that means we actually developed systems to measure those biases, right? So which means that you can see the system on the right, you're actually using things like age, which you normally don't use on any modeling, but we actually do and then check how the models are performing in comparison to a protected variable like age or gender right? So I'll talk a little bit more about this. So we did develop these kind of tools that actually assist modelers to send the models and evaluate for bias and explainability. And the teams that are actually taking these outputs are reviewing this information very frequently and ensuring that the model is fit for purpose. And that means that sometimes if there is a bias there, because let's say it's a small population, a protected population, then do we need to correct the bias? What kind of things we need to do? And these are long discussions that these teams have on a quarterly basis every time they release a new model or anything like that. So let me just explain a little bit this graph that we have here on the left there. So this is a communication from the bank, right? And we're evaluating all the types of communications we had. And so as you can see here, and if you look down the bottom of the list there, we have age in years, and you have a little dot, right? That dot means that the percentage of communication that group of users have received. So if you take the 18 years old, it's 0. So they haven't received that communication. That's probably because of eligibility. So we couldn't send that communication to minors. 18 to 25 years old receive more than 20% of their communication, that particular one. And the other value there says, well, if we didn't have a model, if you only look at the eligibility, what kind of communication they would have received, right? So you generate simulations there and try to see what kind of communication they would receive. And we see that actually that model is giving more that communication that you expect a random chance, right? So there is a slight bias there on that communication. And communications here could be something like happy birthday, right? Could be something like now in the flood period, we could be sending communications to people in the postcodes that they're affected, saying, oh, how are you? Are you okay? Your house is affected. Do you need any help? So this is the kind of communication we talk. So as you can imagine here, because it's there's more communication, it looks like age, even though it's not used in the modeling, is an important factor in this communication, right? So the team then, you pick up this information and look at it. Is this the expected behavior of that communication? And it might be something that is expected behavior. If it's not, then there might be a correction that needs to apply to. So this is the kind of things that we do every day to try to correct the biases and look at, make sure that anything is, our communication, everything that we do is actually done fairly for our customers. And this is pretty much what I had to show. I obviously will take questions in the end, but now I'm going to pass it to Shivan. It's going to talk about the specific techniques that you can use to provide explainability. Thank you.
Thank you very much, Luis, for the great introduction and information about the techniques and some of the ideas that you have been deploying and using from the banking perspective and CBA perspective, to be precise as such. These are very interesting. In my talk, I will talk more about the applied techniques, different methods from a data scientist point of view, from the stakeholders who are more close to data, what type of techniques they can use to really get all those components that Luis mentioned regarding fairness, ethical, security, responsible AI, and so on. So a very quick introduction about myself. Currently, I'm a senior data scientist at H2O.ai, and I work with different teams within H2O that includes product engineering, data science, customer success. Apart from banking and finance, which has been my core interest area, I do have expertise and hands-on experience in other industries such as retail, manufacturing, supply chain as such. I have my master's degree from National University of Singapore, and I'm also a Kaggle Grand Master in 3 different categories, datasets, notebooks, and discussions. And my highest rank was 1 this year, and I'm the winner of 5 different competitions as such. So the first part of my topic will be like a summary of what Luis described, different components, different elements that are part of Whitebox AI as such. So if we have to understand what really makes Whitebox AI, we have to really understand these different elements as such. So very first one is the trade-off or the balance. So from a data scientist point of view or a business person point of view, 2 things are always important. Performance of their solutions, which is accuracy as such, let's say, or the explainability or the interpretability of their solutions. Now, there will always be this trade-off between selection of the models, whether to go with more simplistic models that may not be fully accurate, may not be fully performing well on the new data sets, but they may be more explainable, they may be more close to the white box side. On the other hand, we may have more sophisticated models like deep neural networks, complex machine learning algorithms, but they may be black box in nature as such. So when we want to consider, do we really want to have a right trade-off or a balance between these two metrics, the model selection or the potential balance between feature engineering, algorithms to be used, data to be used, data pre-processing techniques to be used, becomes an important criteria as such. The next part of Whitebox AI element is the multiplicity. When we talk about real-world data sets, generally there are more than one model possible for any business problem. What it means that, let's say we are working on a business problem and we have a data set, but there may be different set of models that can be applied. There may be different combination of the models that may be applied, and multiplicity of models, of good models, become another important metric, another important criteria to really take into consideration when we want to deploy these white box AI models as such. The reason for that is that different models or their combination may lead to different business outcomes, or maybe different business ROI as such. So which one to choose? As Luis also mentioned about different ideas like fairness, is one of the model more fair versus the other, or is one model have more bias, or that may be better, but it is biased toward particular groups as such. So multiplicity is always a major issue when we talk about white box AI. Fairness definitely becomes an important point. While working with many data sets, we may come across sensitive columns like gender, age, race, religion, location, etc. And definitely we need to work on one last layer, or the layer within the modeling process, which can either detect whether there are sensitive columns, whether there is a bias, or we need to take action to remediate this type of a bias and make sure that fairness is achieved within the modeling processes. Trust is an important metric. This is because generally, if we talk about the data scientist, the data that they work on versus the real world data sets, there seems to be major differences. Like this image shows here, like the real world data may have different distributions, different patterns, but when this data is shared to data scientists, they may get a portion of it, and this may lead to trust issues as such. And certainly this trust becomes more important in the use cases and industries like healthcare, where we really want to predict, say, cancer or other life-related use cases related purely based on machine learning. So trust of model producers, that means the stakeholders who are close to data, and the consumer, who is the audience or the end users who will be receiving the outputs of these models, becomes an important metric. The next important element is the attribution. Attribution basically is related to the key drivers or key causal effects from a modeling perspective. When we consider a machine learning model, there are different features that are involved in the model preparation set. And as a white box AI consideration, it becomes important to understand what are their importances, what are their contributions, which features are the most impactful drivers, both at the local level as well as at the global level. Local level means we want to understand at every row which features have contributed the most, and global level means in general what is the general behavior of these models, and that basically comes under attribution element for white box AI. And last but not the least is the regulations, especially in the banking and insurance sectors. Regulations are important, where the key focus is to explain why a model is making particular decision. If we talk about the example of lending, essentially, so if a bank is accepting or rejecting a loan of a person, so regulations would focus on what are the methods, or why a particular model have, let's say, accepted the loan of one person versus rejected the loan of other person's assets. So the whole transparency in the modeling process, data procurement process, data preparation process becomes an important criteria. So if we summarize Whitebox AI elements, these 6 elements are the most important ones that really should be considered when we want to implement or deploy explainable Whitebox AI AutoML related solutions, and make sure that these areas are always touched upon. These areas always have been considered during the implementation of these Whitebox AI solutions. So now let me discuss, I'll walk through from a data science point of view, from a data scientist point of view, how they can address these things. What exactly is machine learning interpretability, and what are some of the key techniques that are available for data scientists, and some of the novel techniques that we have developed as H2O team to really make models explainable. So now when we talk about machine learning interpretability, generally machine learning interpretability is considered very hard problem. The reason for that is when we consider any machine learning model, this is an example of a neural network model, which basically considers some input variable. Then there are internal interaction within these variables, and a lot of complex equations, complex connections goes into these models. And machine learning algorithms consider high degree interaction between these input features. Irrespective of, say, the modeling choice, these type of interactions always exist. Unlike we talk about, say, linear regression models in which single variables can be mapped to the final values, they become explainable, they become easy to understand, but any other machine learning variable will have a lot of internal links between how the input variables were converted to the prediction value, and to reverse engineer this process becomes a challenging part as such. But in the data science field, the machine learning interpretability has seen a lot of growth and advancement, and 2 key ideas that have emerged are to really make the explainable model training process itself. So when we talk about any machine learning implementation or the life cycle of a data science process, it always starts with the data side, data quality, data integration, exploratory analysis, feature engineering, followed by model training, and then we get a model as well as its predictions. Now, the first idea that machine learning interpretability suggests is to constrain these interactions or feature engineering and make this whole pipeline as it is explainable as such. Now, this is the part where we focus on spatial models that penalizes some functions, some variables more as compared to other, that gives more weight to some other variables. And in the end, they align with, say, more interpretable models and align with the human hypothesis that data scientists may have thought about before even running the modeling cycle. The second idea in machine learning interpretability is to follow the same practice, same pipeline, starting from the data to feature engineering to model training, but do add another step, the last step, which is the post-model explainability, where the focus will be to explain the model predictions, to explain the model behaviors, to explain why a model is making particular decisions, what are the key drivers, and what explainability can be built around this model after it has been trained. So when we talk about this perspective, then we have an option to choose a lot of techniques: Shapley reason codes, surrogate modeling, Lime reason codes, partial dependencies, model robustness, model backtesting. These are few techniques that can be applied after the model has been trained. And the goal of all these techniques is to give a perspective, give an idea about all the elements that I described in my presentation just before, and what Luis described in his presentation, focused on, say, fairness, bias measurement, attribution of features, and other causal effects, and so on. So let me walk through some of the key techniques that we use day to day in H2 and as a data scientist are very helpful that in the explainability areas. So the first one is the surrogate modeling technique. Now, the idea of surrogate modeling technique is to have a modeling process which basically consider a normal model, an original model, where we consider a data set having some features and a target. We train our model, which could be a complex deep neural net, it could be a GBM, it could be another complex models. And in the end, we get the model as well as its predictions. Now, when we train a surrogate model will consider the same features as they were present in the raw data set. But instead of the actual target, now we consider the model predictions, our original model predictions, as our target as such. And then we do a training by using a simple decision tree or a linear model, which we call a surrogate model. And the idea is that this surrogate model can really capture the approximate behavior of the original model. This decision tree can be used to understand why this model converted these X values into these Y prediction values, and can give a flowchart in the form of decision trees, which are easy to explain and easy to understand. So surrogate modeling is intuitive technique, but it has some pros and cons, certainly. Definitely, it increases any black box model interpretability, variable interactions can be understood. And from a business point of view, decision trees can give clear and visual explanations. But since this is a surrogate model, this is not the actual model, approximation may not be 100% correct. They may not be 100% accurate. They may lead to oversimplification. They may be a loss of certain information that was captured in the original model. But in general, the global idea or the global behavior can be captured by training surrogate models on our data set, by taking the prediction variable of the original model as the target within the surrogate model. So if we have to, let's say, understand at a general level, if a model makes its prediction in the range of 0.3 to say 0.8, the ideas can be captured to witness or understand, say, which customers are likely to take what path to get a lower prediction, maybe on the close to 0.3 side, and which other customers are likely to take what other path to get higher prediction value, just by following the decision trees. The next important technique for a data scientist and that we heavily use is the Shapley values or the SHAP contributions. And these techniques are really powerful as well because they have a solid mathematical foundation, and they are based on the fundamental ideas of game theory. When we talk about game theory, the main objective is to understand, let's say, if training a model is a playground and all the variables are competing with each other to deliver a goal, to deliver an objective, which is how much prediction should be delivered in one scenario, in other scenarios, and so on. And scenarios here means different training examples. Now, SHAP values tries to rank or tries to prioritize these features and tries to give the contribution effects, or which variable has contributed the most in making those prediction values as such. So it kinds of rank these features based on their individual contribution to really understand a prediction contributions if we break down that into different features as such. So SHAP values provides an estimate of how much each variable contributed to each prediction, which we call as a local SHAP values or local explanation. If we aggregate all these local values at a global level, then these global level feature contributions can be obtained. And also, if we have some transformed features, meaning that we may have some derived features within this modeling process, those features can also be reverse engineered to understand the local feature contributions of original features just by using the SHAP values at individual row levels. And one very interesting property of SHAP values is that they always sum up to the actual prediction of the models. This means that, let's say, if we are working on a problem where the goal is to, say, classify a text, or maybe simple sentiment classification example. So if you pass in a text, Shapley values can be used to break down which portions of this text, which may be keywords, which may be key phrases, have what importance, have what contribution, and how they are added up to, let's say, the final prediction value, which in this case is on the negative side, as we see, is minus 3.7. And Shapley values breaks down different parts of the text that can give the overall or individual feature-wise SHAP values or their contributions. And as I described, if we aggregate them for entire data set, we can also get feature importance like a plot, where The idea is that it can give which features are the most important ones if we consider a global perspective, if we consider the global effect, which features are the most important or the most key or the key drivers that leads to say model behavior to predict something. So Sharp values are really powerful technique, as I described. We use it in multiple banking use cases, be it say credit fraud detection or say lending problems, or even the recommendation systems to really understand what is contributing to different user behaviors or different bank associated behaviors. So Sharp values can give us that story both at local as well as the global levels. The next technique that I would like to talk about is the disparate impact analysis that is linked to the idea of fairness. It also comes under model debugging. Now, the goal of disparate impact analysis is to measure, does the AI have a disproportionate effect on some groups or some classes or some variables, which we call them as sensitive variables. Louis also described a very good example of considering age in one of the use case. But how do we measure whether age is coming out as a sensitive column and our model is maybe under predicting or over predicting for certain age groups or certain genders? Can we consider a technique which can really quantify that type of a bias at a variable level? Now, one idea in disparate impact analysis is to specify what are your sensitive columns, specify a reference group. Let's say if we talk about one example of gender, we can specify, say, unknown category in gender, maybe is our benchmark, and we want to measure how the male's performance versus the female performance of our model is with respect to the benchmark as such. And if we can quantify different metrics associated with these benchmarks, which could be, say, accuracy disparity, it could be, say, precision or recall disparity, it could be true positive, false positive rate disparity, or maybe the adverse impact. Adverse impact is a mathematical or a banking term, I would say, where we basically understand which group of variable got the positive outcome from the model. Now, positive outcome example could be, say, the loan application. So for how many males got loan approved, how many females got loan approved, and if we can divide that ratio, then we measure the adverse impact. And if we get bars like this, as we see in this image, that means that if we have different categories and the model seems to have different adverse impact for different groups, that means that there is some level of bias in our data or in our model, and we may need to correct it. We may need to remediate that bias by either doing some data preparation or removing those features, or maybe tweaking the cost function within our model so that model understand these are the sensitive groups and protected groups as such. And one of the other element I also discussed in my presentation was the multiplicity of the models. Multiplicity basically linked to there may be multiple models possible. So apart from, say, which model is better performing, which model has higher accuracy, adverse impact or model bias is another metric that helps to data scientists to choose better models, because it can really work on that trade-off or a balance that we want to consider models that are not just accurate, but also are fair from the modeling perspective as well as their outcome perspectives. And this is very important for regulated industries, and especially for banks like CBA. We discussed and we saw fairness is a major core part of explainable AI, Whitebox AutoML as such. So the next technique that I want to discuss is the adversarial model robustness, which is linked to security. Now, if we talk about different machine learning models which are deployed in real world, they are mostly prone to adversarial attacks. Now, adversarial attacks are you can consider someone can change some values or weights in the model, and suddenly the model start behaving differently. So if no defense strategies are applied, it may lead to critical security issues, and targeted adversarial attacks on the models can be used to test model robustness. Now, what is model robustness? Model robustness basically means despite of changes at the variable level, model does not behave differently. Model has really learned well which variables are important and what came out to be important from the feature point of view, from the combination of features point of view, from the weights point of view as such. And those models are robust. So irrespective of if someone tries to attack them, if someone try to change the intrinsic values within the modeling part, models will be harder to attack if they are robust enough. And adversarial model robustness is based on the idea of genetic algorithms, where if we take the original data sample from our data and we generate an artificial data point, and we then basically combine them to give a new child, which is a child of, say, original data point and the perturbed data point. So now if we get a new data point or a new data vector, and if we pass that data vector to our modeling strategy, and we can measure if there have been significant dip or increase in the model prediction value based on these variables, then it can be used to understand, is our model really robust or not as such. We have developed this technique in-house as well, where we do take a data set, we systematically select different samples within the data based on their distribution and statistical values. We do this crossover strategy. We do the mutation to generate adversarial rows. We generate a new data set, which is then mixed with the original training data. And our machine learning engine, which is H2O driverless AI, can really understand, first of all, whether a sample is adversarially generated or it is original. At a second level, it can understand, it can tries to make the prediction on both the data points, adversarial as original, and it measures if there have been significant change, and if that change is statistically significant, then we quantify that there is some level of model robustness within the model itself as such. And then we classify these models under secure category versus less secure category versus highly secured categories. So the last technique that I will quickly talk about, that is our recent work with one of the largest bank in US, is to focus on the deep learning neural network explainability, where we focused on unwrapping the cost function or the activation functions into simple linear models, local linear models, as we call. If we talk about deep neural networks, there are a number of connections, number of layers within a network, and if these are being used in the modeling environment to make decisions, then explainability becomes a complex issue. But there is a special case if the activation function is being used as the ReLU activation function, which is rectified linear units. So ReLU activation functions follows a special property that they are stepwise linear. So now we captured this special property of ReLU activation function, and then we tried to simplify the neural network by focusing on not at the global level, but at individual activation regions of these ReLU functions. What we did is we developed an unwrapping strategy where we focused on parts of the neural network. We extracted the ReLU function at every node and unwrapped and disentangled them into simple linear models. And we then captured their activation map. And the activation map was used to understand how the neural network is performing at a very subset of the global data, at a small section of the data. And when we did this for the entire data set and the entire network, we really understood how the model is, how the model looks like at an overall perspective when we break it down to these single local linear models. And once we have these local linear models, then it is easy to understand what are their feature contribution, how the model activation function looks like at different points, how the model is treating different features in different zones. And another interesting idea with these local linear models is that we may come up with, say, hundreds or thousands of local linear models for a single neural network, but those local linear models that have similar coefficient or a similar behavior, and they are local, they have local region connectivity, they can be combined together as well to even give simpler models as well. So technique like this may seem to be very complex in nature, but this one is very useful and very powerful because the idea is that there is no loss in the performance of the model. The accuracy, the performance remains the same, But we get another idea, another flavor with around these deep neural networks is that one deep neural network is made out of hundreds of local linear models. And instead of we focusing on explaining one neural network, we focus on explaining 100 local linear models, which becomes simpler and gives better results as such. So these were a few techniques that I wanted to discuss today, and this summarizes my session as well. Would love to have any questions if there are any, and we'll pass on to Oksana. Thank you very much.
Hey, thanks, Shivam. Thanks, Lois, for the very insightful presentation talks. We do have a couple of very interesting questions. So just give me one second. Let me pull up the list. So I guess this is probably for Louis. Assuming CB has millions of customers, what are the techniques or the feedback loop to analyze your build sense model's performance? I think very less number of customers call you back to inform the predictions are wrong.
Yeah, that's obviously one metric, right? How many people are complaining about stuff, right? Try to minimize complaints around every area. If you think about the model itself, right, there's lots of things we measure, right? As you can imagine, build sense trying to predict bills, right? Trying to predict the value of the bill, trying to predict the timing of the bill. So these are things that we're measuring, like any regression model, trying to minimize the difference between the predicted and the real what we actually had. We also obviously look at engagement as well, how people are engaging with the feature, right? And all of this, we keep close eyes. Obviously, if something engagement drops down significantly or something like that, there's an alert and people can investigate what happened, and all these things that we keep an eye on. And in every other model that we have deployed is right, like whatever you're trying to measure, you're trying to see if the predicted and the actual values are what's the difference of them, right?
Thanks. And the next one is, when do we apply explainability? Is it before feature selection?
When do we apply explainability before selection? Yes, sometimes you do that on the feature selection phase, right? Because you need to be able to explain why you select the features, right? But there's also explainability on let's say complex models if you need to understand what Shivan's explaining, right? Like if you need to explain the drivers of every single decision. So you can imagine if you're providing a credit scoring or a credit card, a credit decision, you need to explain what are the drivers of that specific decision that happened.
Thank you. There's a question around SHAP and LIME. So this is from Christoph. SHAP like LIME has presumptions of local linearity. Does that not void the raison d'etre of non-linear AI? That's deep learning, which captures non-linearity as compared to PCA, etc. I don't know, Shivam or Lois, either of you.
I would say does it really have the assumption? I think SHAP you can actually do with any model. You can simulate the results, but I'll let Shivam answer that one.
Yeah, I would say there are these hypotheses and assumptions intricate to these techniques as such. But why Shapley values have become more popular is because of their more successful outcomes that we have seen in different use cases and so on. Even though, let's say, we consider that the technique itself has assumption, but when we apply on the data set and look at the results and outcomes that are aligned with business hypotheses and so on, that's where Shapley values have gained confidence as such. So despite of assumptions, which I would say are part of every model, every machine learning model will have, every algorithm will have some assumptions, but the main focus is on whether this technique is making sense or aligned with what we are looking for as such. Yeah, not sure this answers the question. I didn't see this question, but yeah, that's my point of view.
Thanks both. So here's one more. If you use adversarial models, how would we be able to identify concept drift or data drift?
Yeah, that's a very great question. I would say I think I mentioned this briefly when I was talking about adversarial modeling as such. The idea will be that adversarial model will have mix of multiple models. The goal of one model can be to understand whether a data is artificially generated, if it is adversarially perturbed, or the other, or is it normal data as such. So if that model qualifies a data point as original versus say artificial, then the user can just quickly take off that data point as such. But if it is classified as a original data point, so then the ideas of concept drift, data drift, covariate shift becomes applicable, and we will go on to measure those feature drift, concept drift on the original data as such. So in adversarial modeling, during the inference side or during the prediction side, the goal will be to first identify if the model has been attacked or not, and which samples have been attacked or not. And if we can qualify that, then the goal will be to remove those samples from the training data.
And I know, like, if you normally use it, as you mentioned, Siobhan, like you use adversarial AI just to identify if the model is also stable, right? You can imagine that a small perturbation in your data shouldn't really change the outcome. But if someone figure out that small perturbation can change the outcome, right? That's particular attack that they're looking at.
Yeah.
So here's another interesting one for Lewis. Fairness is a subjective topic and possibly has multiple definitions. How does CBA define fairness? What are some of the strategies you undertake to avoid unconscious bias not coming to the efforts to maintain fairness? And this can be a lengthy discussion, but Lewis, go for it.
2 minutes, I think we can spend an hour on this. But it is obviously a difficult one, right? Like, but as I was saying, the way we approach this is actually looking at the outcomes of the models and making sure that those outcomes make sense. If they do not make sense, there is obviously discussions on how to do it. But I agree, fairness is a very difficult one to define, right? Like, it's a long conversation, I guess.
Yeah. So just a follow up on that, Luz, again. So you mentioned CB undertakes periodic model reviews to maintain high degree of ethical standards. If you can comment on it, are there industry standards across all organizations? And do you foresee external AI audits similar to tax audits as a mandatory requirement in the future by regulators?
Yeah, we have a very well governed model policy, right? So we have teams that are dedicated to the function of governing models. As you can imagine, like every change in a model normally is documented and reviewed and things like that. There are different, like you can imagine things like self-learning models require different type of governance, right, and controls and monitoring involved in that. So there's teams obviously monitoring. There's teams that are involved with the change. There's controls around this. There's also, one question of whether there's an external audit. I'm not aware of some of this, but we do have internal audits as well, right? So we do have 3 lines of risk across the business. One of the lines of risk is actually audit, which sometimes go into systems and places in the bank and poke around to see if anything it's been done correctly, right? Everything has been done correctly, and if there's fault, if it finds anything that hasn't followed any processes, we obviously raise issues and instances that we then gets corrected along the way. So yeah, it's a low control of these things.
Well, thanks. We actually passed here, but maybe we can take one last question. What are the different algorithms we can use for adversarial security?
Yeah, I can take that. I would say in the recent years, GANs have seemed to be very popular, where generative adversarial networks have been used to synthetically generate data that seems to be original but have differences with it from the original set. And again, the idea, as I described, if a model can be trained, a classifier can be trained that can understand whether it's GAN-driven data or a real data, then it can be used. There are few other techniques that are inspired from the domains of cybersecurity, like poisoning attacks, where we artificially inject some noise within the data and tries to see whether the model is behaving similarly or not as such. In another technique, we try to change the distribution of the data and then understand whether there have been differences in the model behavior, model performance, and so on. Yeah, these are some of the techniques, and the one that we have been using is based on the genetic algorithms, where I shared that we artificially generate samples by doing some mutation and crossover with the artificial data as well as the original data.
All right, thanks, Shivam. I guess I should put a stop now, but thanks, a big thanks for everyone who's attended. Thank you, thanks to Lois, Shivam, and Oksana as well for speaking in this event, and we'll share the recording shortly, and also keep a lookout on the future events that we have from H2O on these topics. Thanks, everyone.
Thank you.
Thanks, everyone.